It's exercise 5, question number 1. There are 15 beads in bag. Uh, there are 7 beads are red. Red 7, 3 blue, and green 5. So 3 beads are selected at random from the bag and replaced. So okay, that's good. And find the probability that the first and the second beads uh, chosen are red and third bead is blue or green. So first and second, red R1, R2, and the third one blue or green. Blue B3 or G3. So probability of getting red is 7 out of 15. Probability of getting blue 3 out of 15, and probability of getting 5, getting green 5 out of 15, and this is with replacement. uh, with replacement. Hence the probability always same. Now here we have two options, probability of R1, R2, B3, or R1, R2, G3. So this is equal to probability of R1, R2, B3 plus probability of R1, R2, G3. The probability of getting red is 705. So PR times PR times PB and PR times PG. So this is going to be 7 over 15 times 7 over 15 times 5 over 15, and this is 3 over 15 blue, and 7 over 15 and 7 over 15 times 5 over 15. So the answer is 3923375. Part A. Part B. 1 red, 1 blue, and 1 green bead chosen. So red, blue, and green. So probability of R fix BG and R fix ORGB. Then let's fix B, O, B, then RG, O, then again B, G, R. So R fix, B fix, now G fix. O, G, R, B, O, G, B, R. This is equal probability of RBG plus probability of RGB plus probability of BRG plus probability of BGR plus probability of GRB plus probability of GBR equal probability of 6 times probability of RBG, because RBG, RGB, RG, the all multiplication. So this will going to be same probability, because this is without replacement. That's why with replacement. What, and then 6 times probability of R times probability of B times probability of G. 6 times R is 7 over 15, B is 3 over 15, and G is 5 over 15. So this is going to be 14 over 75. Part 2. The basketball player has a batting average is 0.341. So basically 0.341, and non-batting 0.659. Addition is 1. The first question, she makes 3 hits. So if I make hit as H, so probability of H, it means probability of H intersection, probability of H multiplied by probability of H multiplied by probability of H. So this is going to be 0.341 times 0.341 times 0.341. The answer is 0.0397. And part B, she makes no hits. It means probability of, let's say, no. Probability of no intersection, no. That is probability of no times. Probability of no times probability of no. It means 0.659 times 0.659. This is going to be 0.286. And C, she makes at least one. Probability of at least one means 1 minus probability of no hits. 1 minus probability of n, which is 1 minus 0.286. That is going to be 0.714. Question number 3. This is a store of score of 250 students. Find the probability that a student is a female. So probability of female is total number of female 128. We'll write 8 plus 13 plus 19, 30, 26 and 32 over total number of students. So this is going to be 128 over 250, that is 64 over 125. Then part B, find the probability that student scored less than 35. Probability of score, this is score less than 35. So what is the total probability? 7, 8, 15, 13 and 18, 19. So 7 plus 8 plus 15 plus 13 plus 18 plus 19 out of 250. That is going to be 80 out of 250, 8 out of 25. Probability part 3 finds out that the student is male and a score between 25 to 34. Um, Part C find the probability that the student is 25 to 34. It means probability 25 to 30, score 30 plus 30 greater than is 35. So this is not an equal sign. So 32, 34, 5 we can consider like this, 30, 34. So for this amount 15, for here it is 18. So approximate value 33. So probability of 25 greater than is greater than 34 is 33 out of 250. Part D. In order to pass the test, the student must score 37 or more. So 37 or more, 37 is in here somewhere, and more. It means 26 plus 30, so 32, and 30 plus 27, and so people, males 40 to 45, they set is past 30 plus, then this is also over 27 plus this is female 26 and then 32, they all pass. And now we have to find the from this 37 to 40 amount. So we will do interpolation. This is 35 and this is 40. We'll do a total interpolation to a total. So 18 plus 19. So first of all, find the total. So this is 15. This is 28. And this is 7, 37. And this is going to be 25 to 30, 55. Now, cumulative frequency 15, 28 plus 5, 28 plus 15, 43, and plus 37, 80, and 80 plus 55, 135. So this is enough. So 35 to, we need 35 to 40. So this is 80 and this is 435. The gap is 55. So we need 37 and after 37 this value, if you take P or let's say x. So you can do a interpolation, um, normal interpolation. Then you can minus the total up to here. Okay, we'll do that one. X minus 80 over 135 minus 80 equal 37 minus 35 over x minus 40 minus 35. So this is going to be 2 out of 5. X minus 80, this is 55 equal 2 out of 5. X equal 80 plus 2 times 2 out of 5 times 55. So when you get this one, you will get up to here. So you know total is so this answer is 102, and now up to here 102, and up to here 135. So 135 minus 102, this is going to be 33. So this amount is going to be 33. Then we have to add 33 to this one. Or another way of calculating this one is now this distance is 55. The gap is 55. From here to here, this total gap is 5. Okay, I will do like this. 40 minus 37, that is 337. So now we have to divide this 55 into, if I need this area, 3 out of 5. If I need this area, 2 out of 5. Finally, that's the answer you will get through the interpolation. So since I need this part, I'll select 3. So 3 out of 55 is 33. Take this, take this 55 and divide to 3 out of 5 ratio, because total is 5. In other way, I will explain. 5 represent by 55. Then 1 represent by 55 over 5. You want 3. 3 represent 5. 55 over 5 times 3. 11 times 3, 33. 11 times 3, 33. Now, this is this total is going to be 148. So probability of RC is 148 over 250. That is going to be 75 over 125. The assumption you made in this making, in between this 35 to 40, the marks are uniformly distributed. That is, marks are uniformly distributed among uh, between 35 to 40. Question number 4, it is a histogram sum. Question part A. Find the probability that baby chosen random has mass greater than 3 kilograms. So this is mass and frequency greater than 3 kilograms. So from here to here. So number of S, let's say B, M greater than 3 is going to be 3 to 3.5, which is the gap is 0.5. We know that the frequency is frequency density multiplied by class width. Uh, this is gap is 0.5 times height is 50 plus this gap is again 0.5 times this height is 30, and this length is 4262. 2 times height is 2. So this value is 44. Then NS is 50. Total number of probability of M greater than 3 is 44 out of 55. 44 out of this is 50 actually. 50. This is 22 out of 25. And part B, estimate less than 3.5 and M less than 3.75. So this should be included. So 2 times 6 and 3 to 3.5, so 0.5 times 50, and half of this distance, half of 0.5 times 30. So half is in again 0.5. This value is 38.5. Probability of probability of m less than 3.75 is m less than 3.75 divided by ns, that is 38.5 divided by 50, or 77 divided by 100, which is 0.77. Question number 5, it is a Venn diagram sum. There are three three programs. One is tone time, other one is okay, other one is skeleton. Now 35 was tone time, 35, and 54 was okay, so this is 54, and 62 was a skeleton, 62 was skeleton, and how many, any number in between, in the middle? Yeah, 4 was tone, pokey, and skeleton, so 4, that's fine, that's done. Then 9 was tone and pokey, so 9, tone and pokey 9, so this is going to be 5. 9 minus 4, 5. And 14 was pokey and skeleton. Pokey and skeleton 14, so 14 minus 4, this is going to be 10. And 12 was tone time and skeleton. Tone time and skeleton 12, so 12 minus 4, that is 8. And draw when going to, so how many? The total is 150. Now I want to find this area. Okay, this amount. First of all, uh, 8 plus 4, 12. 12 plus 5, 17. So 35 minus 17, that is going to be 18. So this is going to be 10, 15, 19, 54 minus 19, 35. This is 10 plus 4, 12. This is going to be 12, 12 plus 4, 14 plus 2, 22. So 62 minus 22, this is 40. Now, I want to find how many remain in here. The total 150. This circle is 62. This whole circle is 62. And then remaining this 3. So 18 plus 5 plus 35. When I add these 3, I'll get 120. So total 150. There are 120 addition. Then this is going to be 30. Now, find the probability that randomly selected child from the study watches none of three these cartoons. So that is going to be probability of none is 30 out of 150. That is 1 out of 5. Question number, no more than one of the cartoons. So it is going to be no more than one. So there are people watch 3 type or 2 type or 1 type only or no one. So no more than 1 means it doesn't matter, nobody watch, and 1. So nobody is there, 30, and 1 only. So 18 plus 35 plus 40. So that total is going to be 41. So probability of no more than 1. So that is 30 plus 18 plus 35 plus 40 out of 150. That is 41 out of 100 and that is 1, 2, 3. So 1, 2, 3 out of 150. That is 41 out of 150. This is A. This is B. So P A is given 1/3. So this is 1/3. That whole circle is 1/3. PB is 1/4. This whole circle is 1/4. And PAO, both. PAO, both is half. With probability of A union B is half. So the formula is probability of A union B is PA plus PB plus PA intersection B. So if now we need to find P intersection B. So PA intersection B is PA plus PB minus PA union B. So this is going to be 1/3 plus 1/4 minus half. So this is going to be all 12. So 4 out of 12, 3 out of 12, and this is 6 out of 12. So this is 1 out of 12. So this intersection area is 1 out of 12. Then this is going to be 1/3, 1/3 minus 1 out of 12, which is 4/12 minus 1 out of 12. So this is going to be 3 out of 12. So this is 3 out of 12, 1 out of 4 in other way. And this is going to be 1 out of 4 minus 1 out of 12. This is 3 out of 12 minus 1. This is 2 out of 12. So 1 out of 6. And now we have the remaining. So A union B we have half. Then uh, A union B complement probability is 1 minus probability of A union B, which is 1 minus half is, this is half. So I'd rather write half mean 6 out of 12 in terms of 12. Now we want to show that A and B event are independent. So PA times PB is 1 out of third and 1 out of 4, that is 1 out of 12. The PA intersection B is 1 out of 12. Hence, PA times PB equal PA intersection B. Hence, A and B are independent. So this is the test we have to do. Question number 7. Which two sports are mutually exclusive? This is cricket, football, and the swimming. To have mutually exclusive, there should be, so cricket and swimming. I can see cricket and swimming mutually exclusive because there is no common element. Cricket and swimming are mutually exclusive as there is no common element. Part B. Determine whether the cricket and football are independent. So cricket and football are independent. Now probability of cricket is going to be 21. So this is 21. Probability of football is uh, 13. 13 plus 4, 17 plus 3, 20, 22. So this is 22. So that is 22. And so PC times PF equal 21 times 22. Actually 21 is not the probability. What is the total amount? Total amount is 38 people, and this is 38. Now PC times PF is, this is 38. 21 over 38 times 22 over 38, that is 462 over 1444, that is 231 over 722. And probability of C intersection F is uh, 13 out of 38. Hence, P C intersection F is not equal to PC times PF. Hence, C and F events are not independent. Question number 8. There are two events uh, J and K. P, O, K, O both. Probability of J, O, K, O both, which is probability of J union K is 0.5. Uh, K but not J. So next one, probability of K but not J. So probability of K not J, joy complement intersect is 0.2. Now when you have two areas like this, K, so this is the K area, then not J. So this is K and this is there. So this is K and not J. It means this is the area is going to be not J. Now you can see this area. So this is the area they are talking about. That is 0.2. And then J but not K, the other way around. Probability of J but not K. Probability of J not K is 0.25. So that is, did I make a mistake here? So we need here K, yes, sorry, K but not J. So this is the area 0.2, K not but. Now this is J we need, not K mean this area 0.25. And we have this one 0.5, 0.2, 0.25. If this is X, this answer has to be equal to probability of J union K equals 0.5 equals 0.25 plus X plus 0.2. So this value is equal, so X value is 0.5 plus minus 0.45. So 0.05. So this value is 0.05. Now determine whether the J and K independent. Now 0.25 plus this is 0.3 and this is 0.25 total. So probability of J is 0.3. Probability of K is 0.25. Then probability J times probability K equals 0.3 times 0.2 times is not equal to 0.05, which is probability of J intersection K. Hence, probability of J times P K not equal to probability of J intersection K. Hence, J and K events are not independent. Question number 9. It is about phone MP3 player. 80% have phone 0.85, and 60% have 0.60, and 5% doesn't have anything, 0.05. So then what is the probability of percentage or probability of P union M? That is for no, or MP3 or both is 1 minus probability of none. So 1 minus 0.05095. Now probability of P union M is P plus PM minus P intersection M. P union, actually this I'll put yeah, I'll stay with this P. Now I want to find the intersection. So probability of bone intersection MP3 pi, I mean P union M minus, sorry, this will come to here, P plus PM, and this will here P union M. So this is going to be 0.85 plus 0.6 minus 0.95, which is 0.5. So this is going to be 0.5. Then this one is going to be 0.35, 8.5. So, and this is going to be 0.1. So P only is 0.35. Now we want to check this event are independent. So PM is 85, PP actually PP is 85, PM is 0.60, then PP times PM, PP times PM, so 0.85 times 0.6 equal 0.051, not equal to 0.5, not equal 0.5, which is P for mobile phone intersection MP3 player. Hence P times PM not equal to PMM. Hence two events are not independent. Question number 10. Here we want to decide A and B are independent. So 1, 2, 3, 4. Only 4 areas we have and one unknown. So we can easily work out x plus 0.3 plus 0.4 plus 0.15 equal 1. Total probability add up to 1. So then x plus 0.85 equal 1, x equal 1 minus 0.85, which is 0.15, and this is going to be 0.15 now. Then this is going to be 0.3 plus 0.15, 0.45, and this is going to be 455, 0.55, and PA is 0.45, PB is 0.55, so PA times PB is 0.45 times 0.55, 0.2475 not equal to 0.15, which is PA intersection B. Hence, PA times PB not equal to PA intersection B. Hence, A and B events are not independent. Question number 11. It is about a computer game. There are three levels. So, for the first level, the probability of getting a diamond in first level and the complement not getting the diamond. So this is 4 out of 5. This is 1 out of 5. Result of this complement not belongs to. And then the second level, D2, 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 this is complement and getting 2/3, 2/3, 1/3, 2/3, 1/3, and the third level D3, 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 D3. So this is complement. And probability of getting it 2/3. This is 2/3, 1/3. So it is half, half. Now, first question is find the probability. Find the probability that we can collect three diamonds. So D1, D2, D3. Probability of D1, D1, D2, D3 is mean PD1 minus times PD2 times PD3. So this is 4 over 5, 2 over 3 and half, that is going to be 4 over 15. Question number 1. And collect only one diamond. One diamond. This is one branch, only one diamond. D1, D2, D3, D1, D2, D3, D1, D2 complement, D3 complement, and the other one is D1 complement, then D2 and D3 complement, and the other one D1 complement, D2 complement, and D3. So probability of exactly 1 is equal probability of D1, D2, D3, C plus probability of D1C, D2, D3 complement plus probability of D1C, D2C, and D3. This branch is going to be this one 4 over 5 multiplied by 1/3 multiplied by half plus this one 1/2 multiplied by 2/3 multiplied by half and plus this one 1/2 multiplied by 1/3 multiplied by half. So this is going to be 7 over 30. The third one is probability of at least 2 diamonds. So she can collect either 0, 1, 2 or 3. At least 2 means 0, 1, 0, 1 or 2. Sorry. At least 2 mean 2 or 3. So if we minus ones, we found out this one and we have to find none. None is this one. Equal 1 minus probability none minus of probability exactly 1. The probability of none is probability of D1 complement, D2 complement, D3 complement. That is 1, 5 times 1/3 plus half. That is going to be 1 out of 30. 1 minus 1 out of 30 minus 7 out of 30. So this is going to be 1 minus 8 out of 30. It means 1 minus 4 out of 15. So 11 out of 15. Question number 12. It's about the factory sum. So A, B, C, 3 factory. Production is 60%, 50%, and the rest is going to be 34%. And from A factory it is going to be 4% defective, and this is 3%, and this is 7% defective. We need to draw a diagram. So we'll draw A, B, C, 3 factories. So this is 0.16, 0.5, and 0.34, and defective none, defective none, defective, non-defective. So this is going to be 4% defective. It means 0.04. Then 0.96 is good, and 3% 0.03 defective. 0.97 is good, and this is 0.07 is defective, 0.93 is good. Now draw the tree diagram and represent and find the probability that the randomly selected component is produced by machine B and defective. Machine B and defective. So that is B 1. Probability of B and defective is B and defective. This is probability of B times probability of D, that is going to be 0.5 and times 0.03, that is 0.015. And part 2, defective. So we have defective can come from this branch, or this branch. So probability of defective is probability of defective from A plus probability of defective from B plus probability of defective from C. So this is going to be 0.16 times 0.04, and from B 0.05, 0.5 times 0.03, and then 0.34 times 0.07. So this answer is going to be 0.0452. This is probability of A, B, 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 C. This is P, D given A. This is P, D given non-defective. This is this one, and this is probability of uh, D given B. So this is probability of D given non-defective given B. So this is going to be probability of D given C, defective from C, and this one is probability of non-defective given C from C. Finally, if we have two events A and B, mutually exclusive, if P A union B is P A plus P B, and independent if P A intersection B is P A times P